Okay, welcome to Learning Target 4 in this first unit on data management. Today we're going to be talking about the rule of sum and exclusion with Venn diagrams. So the rule of sum is when you can actually add two probabilities up, and so we're going to look at what that means. It just means sum, and exclusion just means we're going to subtract something out of there. So we may be adding too much, and we're going to subtract something off. So warm-up question, a recent survey about what sports students participate in is summarized in the Venn diagram. What is the probability that a given student participates in baseball or football but not soccer? So baseball or football but not soccer. And so here you just think about this question and really reading this for the first time, like you're really forced to say, what is this telling me? And so what this is telling you is that there's 8 people that participate in football and baseball, so they're included in that category. So there's 8 people. There's 27 that just do football, and there's 10 that just do baseball. There's 6 that do football or baseball. So they do both, but they also do soccer. And so what this looks at is everybody in their own category, and they're only actually counted once. And so the probability could be 27 plus 8 plus 10 divided by the sum of all of these numbers. The learning target. I know that when counting objects, there can be overlap between categories, and some objects can fall into multiple categories. So this is actually something that you need to learn, and something that shows up on the final exam in a very simple scenario. But students, if they don't really understand this, they still mix it up. I know a Venn diagram can be helpful when dealing with overlap and how the word "or" in problems relates to adding objects. I know that the indirect method provides an efficient way to solve some probability problems. So the indirect method here would actually be, all right, I know how many there are total. I'm just going to add up the people that play soccer or nothing. And those are the people that are not going to be football or baseball. So mutually exclusive. 2 events can happen at the same time. We say they're not mutually exclusive. So if 2 events can happen at the same time, so if you can play soccer and football at the same time, those 2 things are not mutually exclusive. It means there's overlap if they're not mutually exclusive. Non-mutually exclusive events can complicate probability. That overlap complicates things. Venn diagrams are a helpful way to illustrate this. So if you know, oh, this is not like, this is a little bit complicated, I'm going to try a Venn diagram, that will actually help a lot. A little bit of notation. When we see a U like this, like we've got 2 sets, A and B, so football and soccer. Union means like both of the sets combined. So we would say OR is union. It includes both sets, but it doesn't double count anybody. Okay. If you see an N like this, we call it the intersection. You can remember that as like you are in A and B. So you play both football and soccer. So we would say that A and B. But it's not an N, it's an upside down U. But it kind of looks like an N. And so that helps with the word and or intersection. Consider the following Venn diagram with respect to red cards and number cards. So if you have red cards and number cards, A is the set of all red cards, B is the set of all number cards, so there's 40 total. There's 20 overlap, so A and B, and there's A union B would be the combination of both of these, and everything outside of A union B, so A union B not, which is the little line, is everything outside. So we don't often say it like this, but I just wanted to recognize that this is A union B, which would be 46. A or B means you've got your red card or a number card, and there's 46 of those. And there's 6 that are neither. So black face cards are the neither. What is the probability that drawn card is a number card or a red card? So number card or a red card, you would look at both of these things. We call it union B. It's 6 plus 20 plus 20. After you have the drawing, it's really easy just to read them off. So it's all of these, number card or a red card. Notice how I don't say and both. Number card or red card implies that category both as well. So just number, just red, and both. It implies that. So I won't say a number card or a red card or both. Although I'm trying to be as clear as possible when I ask questions, it's just implied. Like you're grade 12 and you're a data management student. So if they were calling all grade 12s to the office or to the CAF, you'd have to go. They're calling all data management students to 607, you'd go. Like you're in both categories. So you're data management or grade 12. You just happen to be both. There's 46. Probability is out of n of s, which is 52. So notice how we still say n of A union B, so the number of in that set. And so the probability of A union B is n of A over n of s, or n over n of s. And so we get 46 out of 52, 88.5%. Or we could say probability of A union B is the probability of each one of them added up. It would give you the same thing. 6 out of 52 plus 20 out of 52 plus 20. And we can actually change this Venn diagram to just include probabilities on it. Okay. Principle of inclusion and exclusion, it's basically a formula. So it's just kind of telling you that if you want A or B, you got to add up probability of A plus the probability of B, and you got to subtract the intersection because you're counting it twice. So if you have this plus this, you take away this because you're counting it twice. That's not a formula that we generally use. If you have the tree diagram, it's just simple just to add them up. So if you want to use formula, you can say A is red cards, B is number cards. So we're going to take 26 red cards plus 40 number cards. We're going to subtract the intersection. So subtract the ones that are in both because we counted them twice. We can't have that double counting. So we still get 88.5. Okay. Here's multiple categories. So we'll actually see Venn diagrams for 2 categories. We'll actually see Venn diagrams for 3 as well. So we've got people that watch the news at noon, 6, and 11. And so we're going to draw a Venn diagram that will go through all of that. So when we see something like this, it's hard if you don't know to draw a Venn diagram to start to figure this out. But if you go to the Venn diagram, you can have a strategy for how to deal with that. So we just draw the 3 circles. I'm going to clearly label A as noon, B is 6, C is 11, and that's kind of in the order of the day, so it helps me understand it. You can do it in alphabetical order to help you understand what A, B, and C are. You can also call it N, 6, and 11. It doesn't really matter. It's just make sure that you've labeled it clearly. Probability that a random viewer watches at least one program. It's really helpful to actually draw the Venn diagram first and then answer the probabilities. So the way we do this is we actually start from the inside out. And so we start by putting the 10% that watch all 3 in there. 20% watch 6 and 11, so B and C. But we've already counted 10, so we put a little 10 in there to signify that 20 is the overlap between B and C. Almost you want to ignore A for a second, so cross it out. It's just for a second, and then you can see that there's 20 here. We keep going that way. 20 is noon and 11, A and C, so we need a 10 here again. 25 is noon and 6. We've already counted 10, so we need 15 more. 50 watch the news at 11. So we've already counted 30, so we put 20% in. 60 watch the news at 6. We've already counted 10 plus 10 plus 15. So the remainder is 25. So that B adds up to 60. and then A, the last number is 5, so that it adds up to 40. The probability that you watch at least one program is like all of the percentages that added up. Watch at least 1, 2, or 3. And so if we add up all these, not these numbers, if we add up these numbers, we can answer that question. So we take 20, 30, 40, 50, 55, 60, 70, 95. So 95 watch at least one program. Watch exactly one would just be the 5, the 25, and the 20. Okay. I notice how, like, just to complete the Venn diagram, I should have said that we would add these up and see what's left. And so 5% is left. So indirect method is very helpful here because we've already added them up to get 95. So we can say, well, if I know 5% is on the outside, that's already done for me. I can use the indirect method. It's just a method to, if it's easier to find the opposite. So I don't want to add those up again. I'll just take 100 minus 5 and get 95. Okay? Exactly one would be 20 plus 5 plus 25. Okay, so here's some practice questions for you. There's not a lot of questions in the textbook had 3 overlapping categories, so I made up 3 more practice. So you can see these questions here on page 42, page 86. But I also just put 3 in here, and I put like partial solutions for 3, 4, and 5 in the PowerPoint. So if you're stuck with them, or you just like you want the solution because no answers in the back, you can actually take a look at the solutions.